Hey guys, in this video we're going to take a look at every single fraction, decimal or percentage question from previous SATs papers going back all the way to 2016. This is the ultimate guide. We're going to jump straight in. Let's take a look at these tricky questions. So first one, tick two shapes that have 3/4 shaded. Now to start with, that seems like a simple question. You're going to be looking for 3 parts shaded out of 4. It's as simple as that until you notice none of these have 4 equal parts. So we got to think about equivalent fractions. Let's take a look here, for example, in this shape. We have 8 parts in total, so that'll be our denominator. And we have 1, 2, 3, 4, 5, 6 parts shaded. So we need to think, okay, I'm not just going to leave it because it might be an equivalent fraction. So 3/4. Can you make 3/4 into 6/8, doing the same to the numerator as you do to the denominator? And the answer is yes. If we multiply the numerator by 2, we get 6. And we must do the same to the bottom to maintain equivalence. 4 times 2 is 8. So if we do the same to the top and the bottom, which is our equivalent rule, we get 6/8. Therefore, this is one of the 2 shapes we have to tick. Down here, let's look. We've got 9 in total. Straight away, I know that this is not going to work because I cannot get to 9 using 4s. I need 3/4. If I'm counting up in 4s, 8, 12, I skip past 9. This is wrong. Okay, so we got 7/9 there. That is not the same as 3/4. Over here, we do have 3 shaded, but it's out of 6. So that's obviously wrong. That is equivalent to 1/2 and not equivalent to 3/4. So that's wrong. This is wrong. Here it says tick 2 shapes. Do you know what that means? We could just tick this one without even working it out. Okay, so that's a good test technique there. If you know you've ruled out the other ones and there's still one left to tick, it must be this one. For those of you who want to just make sure, you would be counting 16 of those equal parts. And if you counted how many were shaded, that would be 12. If you wanted to really just double, triple check to make sure, which is never a bad thing, you have time in the test, you can divide by 4. 12 divided by 4 is 3. Do the same to the bottom. 16 divided by 4 is 4. So those two are equivalent. Next question. A cat sleeps for 12 hours each day. 50% of its life is spent asleep. So this requires you to know that there are 24 hours in one day, because then you know 12 out of 24 is equivalent to 1/2, which you know, or you should know, so you need to learn this if you're not sure. 1/2 is the same as 50%. Again, we're not going to go into huge detail here. This is revision. So half equals 50%. That's because 1/2 is the same as 50. If we multiply the top by 50 out of 100. So multiply the numerator and denominator by 50. We get 50 out of 100. And we know, don't we, that percent literally means per 100. So 1/2 is equivalent to 50%. The question says write the missing percentage. Let's read the sentence. A koala sleeps for 18 hours each day. So that's 18 out of a possible 24 hours. What percentage is this? We need to convert that into a percentage. That's tricky because we can't multiply 24 to get to 100. 24, 48, then we go into double 48. We'd end up at 96. That's not out of 100. So we have to take a step backwards first. Let's simplify 18 out of 24. What's the largest number that goes into 18 and 24? The answer is 6. So we divide both by 6. 18 divided by 6 is 3. 24 divided by 6 is 4. So koalas actually spend 3/4 of their life asleep. That is 75%. Now there's 2 ways to get there. Number 1, you've learned your known facts. 1/4 is 25%. 3/4 is 75%. We need to know those, as well as half is 50%. If not, you could take 3/4, and this would take time. So this is where knowing your facts is much better. And we can make now the denominator 100 because we could do 4 times 25 at the bottom. And we could do the same at the top. 3 times 25 equals 75. That gives us 75 out of 100. Or as we put there, 75%. Next question. This is a reasoning type question where you have to explain, and you're not actually given marks for saying whether he's right or wrong, because it says here, look, explain why he's correct. Let's see what Adam said. 0.25 is smaller than 2/5. So you have to do a bit of maths first. 0.25 is smaller than 2/5. Here we have a decimal, here we have a fraction. We need to make them both the same really for a good comparison. So 2/5, let's turn this into a decimal. 2/5 is the same as 4/10. Now, as soon as we know 4/10, we can just use our place value chart because we know our decimal goes here, that this column is tenths. Therefore, if we have 4 of them, the number is 0.4, or we could, of course, put the placeholder in the ones column. This would be tens, 0.4. So explain why he's correct. You'd have to explain in words. Again, you would write this as a sentence that 2/5 is equivalent to 0.4. And therefore, those 3 dots mean therefore. You'd write it in words, of course. Therefore, 0.4, or we could actually go back to the original 2/5 is greater than 0.25 because 0.4 is greater than 0.25. And again, you might be thinking, wait, 4 is not bigger than 25. No, but look, put a placeholder in. 0.40, very clear now that it's bigger. But you just have to explain that in words, okay? Simple as that. Next one. In this circle, 1/4 and 1/6 are shaded. So it's our job to work out what fraction of the whole circle is not shaded. Straight away, the whole circle would be 1 whole. Okay, that's 1 whole. We need to take away 1/4, which is this, take away this shading, and take away this shading, which is 1/6. Now, straight away, we have a problem. We have fractions and whole numbers. We also have different denominators. So first job, find a number that we can multiply we can make by using 4s and 6s. Let me explain that again. Find a common multiple of 4 and 6. So a number that's in the 4 times table and a number that's in the 6 times table to make the denominators the same. That number for me will be 12. 4 times 3 is 12. Do the same to the top. We can say 1/4 is equivalent to 3/12. Now for 6, we would be multiplying 6 by 2. Do the same to the top and we end up with 2/12. So now we need to start with 1 whole. Take away 3/12, take away 2/12. Well, I'm actually going to change 1 whole into 12s also. Then it becomes a really easy question. How many 12s are in 1 whole? Well, it's the entire amount, so it would be 12. So now we have a simple case of subtracting with the same denominator, so we can just focus on the numerator. 12, take away 3 is 9, take away 2 is 7. That leaves us with 7/12 that are unshaded. Really important to make the denominators the same when we're adding or subtracting or comparing fractions. Always going to be our first step. Next one, I put this in here because it is kind of place value, but it's also to do with decimals. So write the missing number to make this division correct. What do we need to do to 75 to end up at 7.5? And as soon as you see division, with the digits staying the same, you must think of your place value grid. So if we just very quickly sketch this out, you're probably at the point where you can imagine this in your head. Tens, ones, this would be tenths, and this would be hundredths. So we started, or very quickly, put the decimals in here. Remember, decimals don't move. We started with 75, 7 tens, 5 ones. We ended up at 7.5. So the digits moved 1 place down. So we're dividing and we're moving the digits 1 place down. Well, we should know by now that 1 jump in our place value chart is the same as dividing by 10. 10 divided by 10 is 1. 1 divided by 10 is 1/10. So here we're dividing by 10, which is 1 place in our place value chart. And that gets us our answer. Next one. Plenty of questions, guys. This is the ultimate guide. So if you're enjoying this, make sure you subscribe. There's more where this is coming from. Leave us a comment down below. How do you find these questions? In each box, circle the number that is greater. So we have 1.5 or 1.2. We have to know these known facts. This is going to be a really common theme. So I'm going to say it one more time. We need to know that 1/2 is 0.5. We need to know that 1/4 is 0.25, and we need to know that 3/4 is 0.75. That's the bare minimum that we need to know. We just need to know them off the top of our head. So we go to half here. We know it's the same as 0.5. So 1.5 is 1.5. Very quickly now, I can circle this number. It's clearly bigger than 1.2. Next one, 1 and 1/4. This is why we need to know these facts. This is the same as 1.25. Again, 1.3, put the placeholder. It's clear now that 1.3 is bigger than 1.25. 1.30 makes that obvious. Then the next one, 1 and 5/100. Again, this is where, and I'm going to probably draw this 54 more times in this video, we need to know our place value grid, because here we have 5/100. So let's imagine this is the hundredths column, this is the tenths column. If we put 5 in the hundredths, that's 0 holder in the tenths column, and the decimal would go here. So that's 0.05. So we can rewrite this as 1.05 for 5/100. This is 4/10 with 0/100 as a placeholder. Clearly, this is bigger now. 1.4 is bigger than 1.05. The trick there is lots of people will think 5 is bigger than 4 and just go for that one. No, we've got to be really careful. And finally, down the bottom, 1 and 3/5. Now, there is a bit of bonus content, guys, that if you can remember, it'd be really useful. And that's the fifths as decimals. Now, 1/5 is 0.2. 2/5 is 0.4. and it just keeps going up in 0.2s. 3/5 would be 0.6, 4/5 would be 0.8, 5/5 is obviously 1 whole. So we've got 3/5 here, which is the same as 1.6. That's really important. The other way you could look at it is changing 3/5, which I've done at the bottom here, into 6/10, and then whacking 6 in the tenths column, very obviously 0.6. So we can tell here 1.6 is larger than 1.5. Lots of converting there, going from fractions to decimals, classic tricks, and testing your knowledge, guys, of quarters, halves, 3/4, and also as a bit of a challenge there, fifths as well. Next question. The numbers in this sequence increase by the same amount each time. Write the missing numbers. So firstly, we get 3 in a row. The first thing I need to think to do is work out what's it going up or down by. And I like that this has 1 whole, because then clearly 1 whole and 5/8, we've already worked out that it's going up by 5/8. So let's start with this box here. This would be a 2-mark question because it's quite tricky. If we're doing backwards now, we have to take away 5/8. So don't just add 5/8, take away if we're going backwards. So 1 is the same as 8/8. The numerator and denominator always the same for 1 whole. 8/8 take away 5/8, that's clearly just 3/8 there. So we've done the first one. Now it's tricky up here because we have 2 1/4 and we want to add 5/8. So already straight away I'm thinking, okay, the denominators are different. This is a mixed number. This is just a regular fraction. Here's what I'm going to do. I'm actually going to put this into 8. So 2 and 1/4. 1/4 is the same as 2/8. Multiply both by 2, the numerator and denominator. I'm going to add on 5/8. Now this should be quite simple. Hopefully I can just ignore the integer here, the 2. 2/8 plus 5/8 is 7/8. And then the 2 will remain the same. We didn't go past the whole, we didn't make a whole. So the answer there is 2 and 7/8. Wow, amazing. I'm going to tell you something, guys. You probably tell by the timestamps below, we're not even halfway there. Let's keep going. The ultimate guide. These diagrams show 3 equivalent fractions. 3/4, very simple. 9 what? Well, we just need to count how many squares there are in total. Denominator is how many parts there are in total. There's 12 there. Up here, we're given the denominator, there are 24 parts in total. We need to know then the numerator is how many of those are shaded. There are 6 in each row. So this is 18. Nice, simple equivalent fractions there. If you get an equivalent fraction question and it shows you the pictures, use them. I promise you, very useful. Tick the 2 numbers that are equivalent to 1/4. You should know this one straight away. I've said this a million times in this video already, but the next ones aren't necessarily obvious. I'm going to tick it for you now. It's 25/100ths. Now, here's why. If you know your facts, you know straight away that this is 3/4. So it's obviously not 1/4. Doesn't make any sense. You know as well that this is 1/2. So you know that's not. So we can cross those. 2/5. We just spoke about this. If you know 1/5 is 0.2, 2/5 is 0.4. And again, 0.4 is not 1/4. We know 1/4 is 0.25. So the only one left is 25/100ths. The other way, again, to think about it is to write 25/100ths into your place value chart. The 2 would have to go over to the tenths column and you'd get 0.25, just like that. Okay, so these are really important. You can see right here, 25 gets 25 out of 100. These are equivalent and they are the same as 1/4. Next one, circle the improper fraction that is equivalent to 6 and 7/8. So keep the 7/8. We're going to need that later. Let's convert 6 wholes into 8ths. Now there are 8/8ths in 1 whole. So 6 times 8 gets us 48/8ths in 6 wholes. Now we're going to add on that 7/8 we had left over. 48 plus 7 is 55. We have 55/8ths as the answer, which is right here. Classic question. A lot of times, guys, you'll be expected to know how to convert 1 into any denominator. For example, if I said 71, well, it would be easy because it would just be 71 71st, so however we'd say it, okay? So whenever we look at 1, we are looking at the same for the numerator and denominator if we want to write it as a fraction. Write these fractions in order, starting with the smallest. Now, there is one thing, again, did this in a recent video, that it's important to note. There is clearly one that's the largest here, which is 6/5. The reason is this is the only improper fraction. This is greater than 1 whole. 5/5 is 1 whole, so 6/6 is bigger, greater than 1 whole. The rest are just regular fractions, less than 1 whole. But you'll notice something. Normally we say when denominators are the same, we can compare fractions, but we can also compare fractions if the numerator is the same. So if I have 3 of something and 3 of something else, how can I know which one's smaller? Well, you have to look at the denominator. The smaller one here is 3/5 because fifths are smaller than quarters. And that's counterintuitive, but all you need to do, guys, is think if there was a cake, a very wonky cake, can I say, and this was shared between 5 people, and this was shared between 4 people, well, actually, the people sharing with 4 people would get more cake. The fourths would be bigger. The fifths over here, as you can see, would actually be smaller. So just be aware of that when you're putting fractions into an order. Keep going, come on. The length of a day on Earth is 24 hours. Oh, you would have seen this one in one of our walkthroughs if you watched the whole paper. The length of a day on Mercury is 58 2/3 times the length of a day on Earth. My goodness. The trick here is to do 58 2/3 multiplied by 24, and the best way is to split this up. So you're going to start by doing 58 multiplied by 24, and this is actually long multiplication. It's nothing to do with fractions, decimal, percentage, but you'll see why in a minute. 4 times 8 is 32, and then 4 times 5 is 20, plus the 3 is 232. Next up, we want to multiply the next line by 20. So we're actually going to use this placeholder to put a 0 here. 2 8s are 16, 2 5s are 10, and that's 11. So in total, we have 9 there, 3, 1, 1392. And then this is why this question's in this fractions, decimal, percentage video, because we want to do 2/3 multiplied by 24. You might see this in your arithmetic test. This is just reasoning questions. What we can think of is the multiplication symbol is the same as of. So we want 2/3 of 24. 1/3 of 24, we're going to divide by 3, obviously, and we're going to get 8. So 2/3 is 16. So we have 16 and 1,392. If we add those together, we end up with 1,408 hours. I nearly forgot my units then. 1,408 hours. Whoa, tricky question. Really tricky question. Next one. Jack has £400. He spends 35% of his money on a new bike. How much does Jack spend on a new bike? This is just a case of 35% of 400. So let's find out 10% is clearly going to be dividing by 10. That's how we find 10% of a number. So 10% of 400 is 40. So 30%, we just have to multiply that by 3. 3 lots of 10 are 30. So 3 40s are 120. Now we need to figure out 5%. Again, we can use 10% to help us. 5 is half of 10. So half of 40 would be £20. So altogether, 30 plus 5 for the percentage will give us 120 plus 20, which is £140 on his bike. I hope it was worth it. Next one, a book has 276 pages. Amina has read 1/3 of the book. Again, it's always good to do little notes. I like to do bar model from time to time. She's read 1/3 of her book. How many pages are left? So we need to work out how much is left. This is 2/3. The total number of pages in the book was 276. So what we're finding really is 2/3 of 276. So to start with, we're going to divide 276 into 3 equal groups. So 276 divided by 3, that gives us 92. And then once we know each box is worth 92 here for each third, we need 2 of them because that's what's left, 2/3, and we get 184 as the answer. A classic fraction of an amount question, guys. It's just that we had to figure out, we didn't want 1/3. We can't just read the numbers and guess. It's actually 2/3, and that's why it's a problem-solving question. Next up, diagram of a vegetable garden. 2/3 are potatoes, 1/4 is cabbages, the rest are carrots. What fraction are planted with carrots? So again, we've got, so very similar to before, 1 whole, take away 1/4 because that's cabbages, and take away 2/3 because those are potatoes. Again, find a number that is in the 4 times table and the 3 times table. For me, that's 12. 4 times 3 is 12, so 1 times 3 is 3. And then over here, we're going to convert that into 12. 3 times 4 is 12. Multiply the top by 4 as well. We get 8/12. And then once more, we're not going to use 1 whole. We're going to put that into 12ths also, which we know is obviously 12/12. 12, take away 3, take away 8, that ends up with 1/12. So that's all that's left, and that's the answer of how much of the space is taken up by carrots. We're keeping going, guys. This is not ending yet. Amina is shopping. She says, I would like to buy 1/4 of a kilogram of cheese. Now we read this and I would write it straight away. So I've got both options here visible to me. Write 1/4 as a decimal. It comes down to knowing these facts. And you see how many marks in the SATs you can get from just knowing these facts. It is 0.25. Okay. So just learn those facts and you'll get marks. It's as simple as that. Here are 3 symbols. Less than, greater than, or equal to. Write 1 symbol in each box to make the statements correct. This is all about knowing your place value chart. Okay, if you know your place value chart, these questions are easy. So let's put this decimal here. We know that that's tens, that's ones. After decimal, we need to know that's tenths, and after the next tenths, we need to know that's hundredths. That's vital. We need to know that. So 7/10, put 7 in the tenths column. Decimal stays there, put a placeholder. This is the same as 0.7. Clearly then, this is larger than 0.07 because we put another placeholder in. 7/10 is larger. This is in the hundredths column. 7/10 are bigger than 7/100ths. Hundredths get very small. Next up, we have 23 thousandths. Again, past 100ths, we know these are 1,000ths. So if we were to put 23 in the thousandths column, it wouldn't work because we know we can only put one digit in each column. So the 3 stays here and the 2 shifts up to the hundredths and we put a placeholder in. So this is 0.023. Straight away I can see therefore that 0.23 is larger. This has 2 tenths. This has no tenths at all. So be really wary of where they go on the place value table, guys. Next up, Amina asked 60 children to choose their favorite flavor of jelly. Why can't I say favorite flavor? Favorite flavor of jelly. These were the results. What percentage of the 60 children chose orange? Well, there were 60 in total, so we're going to start with a fraction. If it was out of 100, this question would be easy, but of course, no. 15 out of 60 chose orange. Now, I need to somehow convert this into a fraction out of 100 to make a percentage. So I'm actually going to step backwards and I'm going to notice something, okay? And you might notice it too. 15 goes directly into 60. So what I mean by that, I could actually divide both the numerator and the denominator by 15 to simplify this as much as possible. So how many 15s are in 15? Just one. How many 15s are in 60? 15, 30, 45, 60. Think of quarters of an hour. So there are 4. Now look, the magic fraction. What's 1/4 as a percentage? You need to know this. It's 0.25 and it's 25%. So if you didn't know that, you could then jump up. 4 times 25 gets us to 100. Do the same to the top and we get 25 out of 100, which is quite clearly 25%. Next up, tick the fractions that are equal to 20%. So straight away, 20%, 20 per 100, 20 out of 100 is the fraction we're looking for. But of course it's not there. That would be too easy, wouldn't it? So let's simplify this. 20 out of 100 is the same as 2 out of 10. But that's not there either, my goodness me. And we can simplify again by halving both of these. It's 1 out of 5. There we go. Finally, 1 out of 5. So for me, smaller fractions, well, I say smaller, they're all equivalent. Smaller numbers in a fraction make it easier for me to work with. I can also see then, therefore, that 3/15 is equal to 20% because 1/5 and 3/15 are equivalent. 200ths, absolutely not. That's too small. 20 out of 40 is the same as 1/2. 1/20th is way too small as well. That would be just 5%. So those two are the options there. When I simplified it, I could then use the simplified version just to find other equivalents. So having that fluency between changing from fractions and decimals and percentages will help you with marks, I promise you guys. Next up, Amina's bed is 190 centimeters in length and 91 centimeters in width. Looks like a measurement question, but you'll see why. She's making a 1/10 scale. This is why. We need to work out 1/10 of these values. So the length, we need 1/10 of 190. And for the width, we need 1/10 of her measurement there, which was 91. It's important to know that 1/10 of something, it's just a fraction of an amount. We just divide by 10. So 190 divided by 10 is 19 centimeters. 91 divided by 10, we go past the decimal place to 9.1 centimeters. I put that in there because it's important to know 1/10 is the same as obviously 1/10, and then a fraction of an amount, we just divide by denominator. We're nearly there. Come on, the ultimate guide. So much help here. Potatoes cost £1.50 per kilogram and carrots are £1.80 per kilogram. Jack buys 1.5 kilograms of potatoes and half a kilogram of carrots. I'm going to start with the carrots. So half a kilogram of, and each kilogram is £1.80. So what is half of £1.80? That is going to be 90. And I'm going to write it like this, 0.90 as pounds. So that's 90 pence. And then over here, 1.5 kilograms of potatoes. Well, 1 kilogram would be £1.50, so that's guaranteed. Now we need to add on this extra half. What's half of £1.50? I'm going to write it again, formally like this, is 0.75 pounds. So we've got our total here of potatoes by adding these together, and we end up with £2.25 on potatoes. So £2.25 on potatoes, 90 pence on carrots. So how much change does he get from £5? Well, let's work out how much in total he actually spent first. So £2.25 plus 90, that's going to give us 5 in the 1p column, 1 in the 10p column with 1 exchange to the pound, 1 plus 2 is 3. So he's actually spent £3.15. We can't stop there. This would be a 2-mark question. We get 0 marks if we stopped here. To get 1 mark on a 2-mark question, you need to do every single step, but you might have just done one arithmetic error. £5 here, subtract £3.15. I like to do a number line for this, so I'm going to start at £3.15, and I'm going to jump up to £5 to find the difference. You'll see shopkeepers sometimes do that when they're counting up change. £3.15 to £4, that would be 85p as a jump. So 85 pence. And then obviously 4 to £5, that would be £1. So the change that he would get would be £1 and 85 pence. Perfect. A lot of other types of questions in there, a lot of other strands is what I mean, not just fractions, decimals, and percentages, but you can see how it overlaps. It comes up a lot. Tick the fractions less than 5/8. So again, multiple ways you can do this. You can change these into 8s if you like and use equivalent fractions. So for example, 1/2 would be the same as multiplying both by 4, 4/8. So 4/8 are less than 5/8, obviously, so we tick that. 2/8 is obviously less than 5/8. 3/4, again, if you write that as 8s, what we're going to end up with there is 6/8. So leave that blank. 6/8 is not less than 5/8. 7/16. So what I do in this case is I'd make 5/8 into 16th. So here we're actually asking, tick the fractions less than 10/16. Well, actually, yes, this is less than 10/16. And down at the bottom, again, I would change 5/8 into 30 seconds. And 8 times 4 is 32. 5 times 4 is 20. So this is not less. 24 32s or 30 seconds or 30. I know I get confused with that one. Is not less. So they're the 3 that we have to tick there. Again, an equivalent fractions question, really. In a race, Ali completes a swim, a run, and a bicycle ride. The swim is 1/10 of the total distance. The run is 3/10 of the total distance. What fraction is the bike ride? So this is just a simple case of thinking that the race is obviously split into tenths. So I'm going to do this very badly now. 3, 4, 5, 6, that should be 10 spaces there. 1/10 was the swim, so I'm going to put an S here. 3/10 was the run, so I'm going to put an R, R, R. So how many tenths are left over? Well, we've used 4 tenths up, so clearly the remaining is 6 of them. So the answer is 6 tenths for the bike ride. 4 tenths was taken up at the other stuff. 6 tenths gets you to a whole. 6 plus 4 is 10 tenths, which we know is 1. Circle the improper fraction that is equivalent to 2 and 3/8. Well, let's keep 3/8 because we're going to need those. But how many eighths is 2 the same as? Well, 1 is 8/8, so 2 is 16/8. Then add back on that 3/8 we saved from earlier. We end up with 19/8, which luckily for us is right there. Very common question. We had this one earlier as well. Remember, this is every fraction, decimal, percentage question in the last 5 years or so. So loads and loads of questions here. Write the missing values. 3/10 equals what 20th? Well, 10 times what is 20? We need to figure out that's multiplying by 2. Do the same to the top and we get 6. Down here, we're not multiplying, we're actually dividing. 12 divided by what is 4? We're dividing by 3. Do the same to the bottom. So for equivalent fractions, multiply or divide by the same amount to maintain equivalence. 15 divided by 3 is 5. And there are the answers for that one. Draw 4 lines to match each fraction to its equivalent decimal. Okay, so we just need to know these. I'm going to assume, because I've said it so many times, that we know the ones I've spoken about. 3/4 is 0.75. Now, 3/10. Know your place value grid. Okay, your decimal goes here, and this is where your tenths go. So 3/10 would be like putting a 3 in the tenths column, which clearly is 0.3 now. So we match that up to the top. Same for this one here, 300ths. This is the hundredths column. If I said to you, write 300s, you'd put 300 in the hundreds column. 3,000 in the 3 in the thousand column. If I say 300ths, I want you to put 3 in the hundredths column. The decimal doesn't move. With those gaps we put in a placeholder, 0.03. Boom, we've got it. I'm going to say it one last time. You need to know your halves, quarter, and 3/4 equivalent to decimals. We just need to know it, guys. It's as simple as that. Write the missing fraction to make the addition correct. Straight away you should think, whoa, the denominators are different. So let's change this into sixths. 3 times 2 is 6. Do the same to the numerator. We get 4/6 plus something equals 5/6. Now it's the easiest question in the world. If I said to you 4 grapes plus what equals 5 grapes, you'd say 1 grape, obviously. Well, I'm saying 4/6, so obviously it's 1/6. And we just make sure we put it in the box. Any working out we do, just make sure you put your answer in the box where it's supposed to go at the end. Last couple of questions. Part of this 10 by 10 grid is shaded. Tick the fractions that represent the shaded part of the grid. First thing to note is how many small parts do we have in total? Well, it's 10 by 10, so that's 100. This is a 100 grid. Now, how many are shaded? Well, if you know anything about these 100 grids, you would have seen them in school plenty of times. Each column or row is 10. So we actually have 4 columns here, which is 40 out of 100. Straight away, I can tick 40 out of 100. But I want you to notice something else as well, something that we do teach in school, that each column is the same as a tenth. So 40 out of 100, actually we could also say there are 4 columns and each one's a tenth, so that's the same as 4 tenths, which means we can also tick this one. Now, we're not done there. 4 tenths and 6 tenths clearly can't be the same, so I'm not going to tick this one. We have 1/4 and 2/5. Now, again, 4 tenths, we can simplify 4 tenths. Divide it by 2 at the top, we get 2. Divide it by 2 at the bottom, we get 5. 2/5 is equivalent. So just check your equivalent fractions. 1/4, we know 1/4 is 0.25 or 25 hundredths because I've said it a million times. Now that would mean 25 shaded. Of course, 40 hundredths is not the same as 25 hundredths. So this is wrong as well. Those are the 3 boxes we needed to tick and we have made it. This is the final question, guys, for the last time. Please like this video. Please share it with someone who you think it'll be helpful with. This is the ultimate fraction decimal percentage guide for reasoning in SATs papers. Let's take a look at this final one here. The full price of a t-shirt is £15. The price is reduced by 30%. What is the reduced price? So we need to take £15. And we need to firstly work out what 30% of that is. Well, 10% we would divide by 10. 15 divided by 10 is £1.50. So what's 30%? Well, 30% would be 3 lots of that. 3 times £1.50 is £4.50. But that is not the answer to the question. What is the reduced price? So it was £15. And I'm going to put 0 just to make sure. We need to take away £4.50 because there's been a 30% reduction. And we can do that now. 0 is obviously 0. 0 take 5, we need to exchange here. 10 take 5 is 5. Put your decimal in, else it's going to be a really expensive shirt. 4 take away 4 is 0, and then 1 is left on its own. The final answer is £10.50. And guys, that was every single fraction, decimal, and percentage question from the last 4 or 5 SATs papers. The ultimate guide. Really hope you found it useful, and we'll be back soon for more videos like this because you seem to enjoy them. Let us know in the comments if you found it useful and what you want to see next time. Time maybe? Who knows? Let us know.